Hey everybody, David Shapiro here. We have a very, very special podcast today for our decentralized future. In this podcast episode, I interview Professor Franconi and Ohad Asor from Tau. Now, Tau is a company, it is a startup. Well, it's been around since 2015, and they are working on decentralized artificial intelligence, but it's a kind of artificial intelligence that you might not be familiar with. It is incredibly disruptive, and it's pretty complex, and that's why this episode is so long. But just to give you kind of a preview as to what this technology does, is that it decentralizes the development of software. Now, that might sound very simple, and conceptually it is simple. There's a lot of problems that go into that. But the other thing that it does is it creates a store for all human knowledge as it develops software and solves problems. And so because of that, the network gets more intelligent over time and gains new capabilities over time. And that has just absolutely profound, astounding implications, which we get to by the end of the episode. So I just wanted to give a brief introduction, and then we can go ahead and dive into the episode. So I hope you enjoy this interview with Professor Franconi and Ohad of Tau. Thanks everyone for joining this episode of Our Decentralized Future. Today's episode is really exciting. We've been looking forward to it for quite a while. I've got with me Professor Enrico Franconi and Ohad Asor from Tau. Now, these folks have been working on the Tau network since 2015, I believe. And this is an incredible technology. It took me a little while to understand it. And once I did, I realized this is the way of the future. And so when they reached out to me and asked me to host this episode, I said, yes, absolutely, let's do it. So without further ado, I'd like to introduce my guest today. So first we have Professor Enrico Franconi, who is, welcome, who has been, like myself, a lifelong problem solver. In our introductory discussion, he told me all about how he just loves solving tough problems. And here we are working on very difficult ones. So Professor, would you like to give us a couple words about yourself to introduce yourself?
Okay, thank you. Well, I'm a professor in computer science in general, but more specifically in AI and knowledge presentation since more than 30 years now. And what I like to do and what I believe is the right thing to do in the field of AI is to provide technologies that make sure that whatever system you build based on AI can be trusted. So, and we know that the science of trust since 2000 years is logic. And so basically this is leading to a scientific field, research field, which is called computational logic. And the computational logic applied to AI brings to what is called now logical AI, which is what I'm doing. And I found in Tau a group of people, very smart group of people that have the same ideas, the same goals as my research goals. They, of course, want to make a real-world system, while I'm just a professor from the university doing research. So I think that joining these efforts is something very interesting.
Excellent. Thank you so much for the introduction and for being here today.
Sure. Well, I'm a lifelong mathematician and software developer, and I founded the project Tau back in early 2015 after someone from the internet told me, someone anonymous told me about an idea, about the necessity and the idea for a blockchain to be controlled by its users. He came up with some initial design, but it changed a lot since then. Mm-hmm. And that's how it all started.
Excellent. Yeah. So speaking of blockchain, that is one of the major technologies underpinning the Tau network. But before we get into some of the technical details in the history of Tau, let's ask the big question for our viewers. what is the general goal is to create this decentralized network? Can you guys give us a little bit like a high level overview? What is the goal of Tau and of decentralization? Anyone who would like to go first? Professor Franconi or Ohad?
In all existing decentralized networks, there is some big elephant in the room of something very centralized that everyone somehow ignores, maybe not everyone, which is the centralized development team. How can we seriously take a decentralized economy like, I don't know, Bitcoin, controlled by a bunch of computer geeks like me? How can it be any wide enough shoulders to carry the whole world? The centralized control of the development team is a big bottleneck for adoption, and it is a problem by its own. Who promises that the decentralized development team will take the right economic decisions? And indeed, they themselves know this, and therefore they avoid taking economic decisions. How can we decentralize in a sound way, in a constructive way, how the network itself should be like? And that's what we do.
So to say that in another way, the goal is, as you said, to take control away, but not from everyone, but to take control away from any kind of centralization and distribute it to everyone who participates in a network. And the example that you gave is like Bitcoin or other economic networks, so that way everyone has a stake in deciding not just what the network does or what the organization does, but how it is coded, correct? Like even participating in the development and building of that network. True?
That's right. You can look at it from another angle, from the angle of software in general, not necessarily decentralized networks. Software is there for one and only one thing, which is the users. Software is only for the users.
Mm-hmm.
But somehow, the users have little to no voice or influence on how the software should be like. Next time your phone's asked to update itself, how does it feel? Who knows what they put there? It doesn't feel good. But it's all for the users. You are the user. Why you don't have control over this? Well, there are very serious theoretical, practical, social problems associated with it. You can ask, how can a large group of people, a whole audience, take any collaborative decision, whether it's blockchain or software or anything? That's a big problem by its own. And then you have an even bigger problem. How can a large group of people not only take a decision together, but even have a discussion? How can 1 million people have a meaningful discussion all together? And those are indeed problems that we address. Upon the theoretical problems, there are some very deep theoretical problems here that we can speak about.
Right.
And yes, and methodological problems, and we can speak about everything.
Yes. Yeah. So the conceptual problems, like you said, it's a matter of organization. Is one thing. Is for anyone in the audience who has ever participated in any kind of software development or any kind of concerted group effort, organization becomes intractable once the group gets too big. But with technology platforms today that affect everyone, to your example, everyone uses phones, computers, whatever you're watching this video on today. There's a lot of control and management that goes into that, but then countless hundreds, thousands of developers that go into that effort. And organizing that is not a solved problem. And as you mentioned, there's conceptual and methodological topics that we'll delve into in just a little bit about how to solve those problems. Professor Franconi, did you have anything to add to kind of the overall goal of the Tau network?
Well, when you have this goal of involving so many agents participating to this effort, then something that you have to something that you have to think about is how these agents, these 1 million people or whatever, even more than 10 people, can trust the system that is helping them to take decisions. And clearly, the good old way of discussing. So I hear you, you hear me. I try to understand what you're saying. If I don't understand, I ask you for clarification. You reply. You meanwhile understand what I'm saying. So there is a protocol in communication that help us to understand each other and to reach an agreement. And this protocol follows, as we know since 2000 years, logical rules. So the notion of argumentation and syllogism studied from the ancient Greek philosophers and so on, and logicians in the 19th century and the 20th century. However, when we want to scale up, you want to say, well, we can't really imagine a protocol that involves discussion and tries to understanding and so many agents, even just more than 10, whatever. We realize that our everyday life, if we try to make a meeting with more than 10 people, I mean, unless you have a major coordinator that tries to understand everyone and try to mediate, then this discussion is not going anywhere. However, even this mediator cannot do anything if there are 100 people in the room. So how do we reach agreement? And how can we trust, and how the user can trust this agreement? Then this is where logic comes in. So this new protocol of argumentation and discussion and finding agreement is, in my opinion, has to be grounded on logic, on the idea that whatever decision the system takes is can be trusted. And what is interesting, I guess this will be discussed in depth later, is that in the logical language of Tau allows also to discuss the protocol on how we reach agreement, and we can define, so user can agree on how they will agree from now on. Again, and understanding fully and trust on this new form of agreement potentially. And so that's my perspective on whatever I had said before. So my contribution, my interest is in this logical foundation of all these things.
Okay, excellent. Thank you so much. So to summarize another function of Tau, so one part is developing software in a decentralized manner. But the other part of that, or I guess a problem that you have to solve to do that, is coming to consensus with large groups of people. How do you collaborate and come to consensus with arbitrarily large groups? And that's what you're talking about with coming up with logical protocols and such in order to arrive at those agreements or arrive at consensus. Is that a good summary?
Yes. Yeah.
Okay.
Yeah, I would say that in
Excellent.
the perspective of Ohad, just to mention, to specify this summary. So in a sense, also this protocol is a piece of software, is a procedure that regulates this conversation, these argumentations. And as such, it will be subject to the same ways of being developed and understood and agreed upon as the general software development or consensus finding in Tau.
Okay, excellent. Yes, and we will delve into Tau's particular solutions here in just a moment. But a quick preview for the audience. So some of the things that they've worked on, and this is not an exhaustive list of the breakthroughs that they've had. One is the Tau meta language, the Tau language, and the Agoras token. But we'll get into those in just a little bit. So thank you for helping get us oriented as to what are the problems that Tau is trying to solve. But let's take a step to the side just for a second, because what I want to do is just spend a few minutes informing the audience, for anyone who doesn't know what a DAO is, a decentralized autonomous organization, and how that relates to other existing technologies like blockchain. Ohad, would you like to kind of introduce the concept of the DAO and the blockchain?
I can try. DAO is indeed something that intended to be an organization that is controlled by the users, that is decentralized, and typically they do so by very basic means. So remember that I asked before, how can a large group of people can reach agreement? Well, voting. That's the method that comes to mind, and that's what existing DAOs basically do. But maybe to take a step ahead, there is one fundamental problem with voting. The problem is that even though everyone have equal right to vote, it is still not the case that everyone have effectively equal right to propose what to vote over. Because even if you have the right to propose, who is going to even read 1 million proposals a day? So even if everyone have right to propose, it is by no means effective. So what people do is create hierarchies that in particular determine what to vote over. But then you get huge loss of information, and your opinion, no matter how good it is or correct it is, will most likely not be incorporated. And this fundamental real-life problem is also reflected in the DAOs as we know them.
So one of the chief, well, so there's a few problems that you elucidated here. So one is at present, one of the ways that everyone is familiar with in terms of making group decisions, large group decisions, is voting. But there are some problems with voting, and we'll get into that. But then also, as you said, even just integrating everyone's feedback, that's a huge problem. And that goes to the problem of anytime you have more than 10 people in a room, you can't hear everyone. You can't get everyone's opinion. But then if you get to the scale of thousands, millions, whatever, you have to, as you say, you have to delegate or create hierarchies. And one of your points is that DAOs have not fully solved this problem yet. So this is something that differentiates the Tau network from an ordinary decentralized autonomous organization, correct?
Yes, very much so. So you can look at it as using the economical term of diminishing returns. So in economy, diminishing returns means like a typical example is that each new team member in a company contributes less than the next one. So if you have 10 people and you add another one, it's not going to be 10% addition, it's going to be less. Similarly, in discussions, if you double the number of participants, you are not going to get double the outcome. And at some point, you are even going to get negative outcome. And indeed, our solution solves this problem completely in the sense that if you will have 100 times more people, you will have 100 times more utility, at least.
That is a big claim, but I believe it. And hopefully by the end of the episode, our users or our viewers will believe it too. Professor Franconi, previously we talked about some of the specific problems, conceptual problems with this in terms of, and also Ohad, either of you feel free to jump in, but the limitations of language, of English language or German, French, any naturally conceived language. There are limitations that also help, or I guess prevent, agreement or that utility. So what I would like to do is ask, what are some of those limitations, and what are some of the solutions, conceptual solutions to the limitations of human language or even formal logic as well?
Okay, I would not say that the natural language is limited. It's actually, I would say the opposite. So the natural language is too powerful. Indeed, I can say whatever kind of concept as abstract as it could be in natural language and explain it to you. So the problem is exactly this one. If you want to translate a communication, so a movement of information from an agent to another one, from an agent to the centralized system, whatever, we need to be sure that we understand each other and in the context of concepts which are known. So when we communicate, say as human in natural language, for example, we need to know two things. We need to speak the same language, both English speaker, for example, but also we need to have the same conceptualization of the word. So you have to not only to understand English, but you have to understand the meaning of words. When I say elephant, I need you to be sure that you know what an elephant means. Maybe if you are a child that never left your village, whatever, in northern Carolina, then maybe you never seen an elephant. Maybe you don't even know what an elephant is. So it's not only a problem of knowing English, is having concepts associated to words. And if you put an agent, which is a computer, in this game, of course, I may try to teach the computer the grammar, the language, the English language, for example. It's very hard because there are so many variations. But the heartbeat is to be sure that the computer, the agent, understands the concepts. And for example, this is the major limitation of language models in AI based on deep neural networks nowadays, like GPT-3 and stuff. So they circumvent the problem of the complexity of the syntax, of the fact that the language is very many things can be said in any concept can be expressed in many different ways, and it's very hard to enumerate all of them. So what GPT-3 does, and all these natural language models based on deep learning AI, they would just digest all the possible sentences ever uttered on the internet, so that statistically they basically get an idea on how the language is built. But the major limitation, which is a center of a very interesting debate in AI with Gary Marcus and stuff, is what the computer understands about the concepts which are embedded in the words. So you can connect words in apparently meaningful sentences because they resonate well to our cognition, but the agent would never understand exactly the content. So that's why when we deal with natural language, we have to focus on meaningful fragments of it. So we will never allow complete natural language freely spoken. So because we want to be certain that we understand 100% of what any of the million agents is going to say. So this means that the computer eventually, the software that controls Tau, this communication, which is also generated by discussion in Tau, etc. But this is another story. But we have to be sure that the definition, the meaning of all the concepts and the words is present in the agent, in the main agent itself. And so this means that maybe at the beginning, Tau will be very stupid, will understand very few concepts, and the conversation among agents will teach the computer more concepts, but in the real sense, right? So definitions, what is an elephant? Well, it's an animal that lives in some countries, it's gray, has a trunk, whatever. And then of course we'll I don't know, we'll have some notion about the object, the concepts that people may want to talk about. In this way, we have limited the focus in communication to what is called normally in research and application in computer science, controlled natural language. So we limit the syntax to be usable enough by everybody, so we cannot speak freely. It's just like me as a foreigner, not as a native English speaker, I would speak English. So subject, verb, object, right? It's a very simple sentences, not so simple, but again, somehow a language is sort of this international English that everybody would understand and would be able to use. Plus the fact that we understand all the words, all the concepts that are embedded in this natural language. So somehow, unlike we were saying, is the limitation of the natural language that is unlimited, and we want to limit.
Yes, yeah. So that because it's so powerful, you introduce problems like the flexibility is computationally difficult, but also the ambiguity is a major problem of not just syntax but the meaning of individual words. And Ohad, I remember you had mentioned previously the mathematical aspect of language versus controlled language. Would you like to add a little bit to what Professor Franconi just shared?
Maybe just one thing, because Professor Franconi basically covered a lot, which is the concept of decidability. There is the question, when you have a computational task, for example, the task for finding a contradiction among statements, it turns out that there are many computational tasks that cannot be solved in finite time. They need infinite time.
To be correct.
Those tasks
To be correct.
to be correct.
Yes. Because you can do a
Yes.
finite computation and be incorrect, right?
Yes. And this case is called undecidability, the things that you cannot solve in finite time. Now, what people in the field of logic do, they define languages and they ask whether any statement in this language contains a contradiction is decidable or not. And then if yes, then you call the whole language decidable, and if not, you call it undecidable. It turns out that even very simple languages are already undecidable. For example, the language of arithmetic, the natural numbers 1, 2, 3 with addition, multiplication, is already undecidable. And this is the famous Gödel's completeness theorem from 100 years ago. There is the trade-off between expressiveness and decidability. The more you are able to say in the language, the less decidable it becomes. And in particular, natural language, because we can express arithmetic in natural language, then of course natural language is undecidable. There is another problem, which is about consistency. Some languages contain a contradiction in the very definition of the language, or let's say you can construct sentences that are not true and not false. And in natural language you can do so indeed. Maybe the archetypical example is the liar paradox. It's a sentence that cannot be true and cannot be false. So you want a language that is consistent and is decidable. In the programming language world, there is the concept of Turing completeness. A language that can express anything that the theoretical construction of what is called a Turing machine can do. And indeed, programming languages try on purpose to be Turing complete. For people who remember how Ethereum began, their main goal was to have smart contracts in a language which is Turing complete. But Turing complete languages are undecidable. The task of asking questions about statements in Turing complete languages, in particular asking whether two programs will return the same output, whether two programs are equivalent, is undecidable. Now, one thing that sometimes people neglect is that you don't need to be Turing complete. You need Turing completeness no more than I need shampoo. Because Turing machines, they are mathematically equivalent to ordinary computers completely except one point, that they have infinite memory. They are equivalent to computers with infinite memory. So you are never going to have real Turing machines anyway. And taking the example of arithmetic I said before, there are infinitely many numbers. But guess what? Only mathematicians care that there are infinitely many numbers. There are, but no one cares. Physicists don't need them, programmers don't need them. No one cares that there are infinitely many numbers. When did you ever run out of numbers? You don't care. You don't need it. It is true that there are infinitely many numbers, but you don't need it. I'm not going to say that the way we achieve decidability is by limiting the machine's memory or by assuming finitely many numbers. We are doing it differently. We achieve decidability while maintaining the infinite. But I am pointing out that you don't need to go to undecidable languages. You can stay within decidable languages and enjoy the decidability of being able to get answers to your questions. Or another way to put it, there is an algorithm that gives answers to questions. And decidability, one way to say it, is to say there is no algorithm. You want languages with algorithms that tell you whether something is true or false.
Yeah, by just picking another side of the argument of Ohad, this is important to have a decidable language with an algorithm that actually exists and then terminates, which has to be correct. So then all the notion of decidability is based on the fact you want an algorithm that finds exactly a solution to your problem. And maybe for that particular problem, such an algorithm that terminates does not exist. So now we want to have decidable languages, namely that the language for which such an algorithm that terminates exists. And this algorithm has to find the correct answer to your problem. And the only way to do that is not to let programmers in a software house to build these programs that always that terminates, but to employ mathematicians, logicians, that generates algorithms together with a mathematical proof that this algorithm does do the right thing, and these algorithms terminate and exactly with the right answer. So I go back to my very first statement about trust. So if you employ logic in this whole endeavor, you are guaranteed that the algorithms do the right thing. There is a theorem proving that. So you have not to worry about whatever the computer tells back to you. Moreover, you can decide what the process that the computer takes to give you an answer.
Excellent. Thank you guys for that that answer. These topics are so fascinating to me, and I think that they'll be fascinating to our audience as well. So we've set up two pillars, right? Collaboration and consensus and the problems with that. And then we've also talked about language, controlled language, decidability, and completeness versus incompleteness. So now let's link the two conceptually. How do the problems of completeness or intractability relate to collaboration and consensus? And this will also lead into Tao's solutions. How have you guys solved these problems and brought everything together? Ohad, would you like to start?
Yes, in fact, there is one big problem that we didn't speak about. Because the problems that we did speak about up until now have solutions in the literature of mathematical logic. There are decidable languages, there are solutions. But there is one big problem that has no solution, and we had to invent a solution. And the problem is a language that can speak about truth of other sentences in the language. Logicians proved that in a certain form, such a language cannot be consistent. It must contain a contradiction. This is called Tarsky's Undefinability of truth. But there is a serious real-life need in being able to do so. So we needed to find a way to have maybe a more limited setting, not exactly the setting that Tarsky considered, but still allowing us to speak about truth of other sentences. And this, we can relate it with two examples well, maybe three examples, to blockchain, to AI, and to real-world law. So we spoke about blockchain that is controlled by its users. Taking it more down to earth, so in each block, you are going to have the code of the network itself, a definition of what the network should do. The whole point in blockchain is a condition of accepting or rejecting a proposed block. For example, in proof of work, you accept it if the hash satisfies certain conditions. But if the block contains statement of the network itself, and the current network needs to speak about those statements, ask questions about those statements, all in the same language, otherwise you're going to need infinitely many languages, and get an answer. So that's a blockchain example. take an AI example. There are the 3 laws of robotics by Asimov, that a robot will never harm humans and so on. I say that you need a 4th law of robotics, which is that any future software update of the robot will also admit the laws of robotics. You don't want to plug in a USB key to the robot with software update and it starts killing people. You want the robot to reject this update if it does not admit the laws of robotics. This is the same problem that the current field of mathematical logic cannot handle. The update is written in the same language that the robot is written. You need the same language to ask whether another statement in that language is consistent with another statement being the laws of robotics. The 3rd example, the law of changing the law. You have law, all right. Now you also need laws of changing the laws. Because if you don't have laws of changing the laws, then either you cannot change the law, or there are no conditions of changing the law, and the law is meaningless, you can always change it. So you need laws of changing the laws. But then you are going to need laws of changing the laws of changing the laws. Because if you don't have laws of changing the laws of changing the laws, then you cannot change the law of changing the law, and so on. So you are going to need infinitely many laws just to begin with. What are you going to do? Well, you need the laws of changing the laws to refer also to themselves. For example, imagine a constitution that says if a proposed law contradicts the constitution, then it needs 60% majority. Otherwise, it needs 50% majority. Those 3 examples are all about the same thing. Language that can speak about truth and contradiction of its own sentences. And this was our biggest theoretical effort, and we achieved that. And then we had to move on to the second theoretical effort, which is after we achieved that, this language has to be able to be a software specification language, because we are all about software controlled by its users, production controlled by its users. Software specification languages are characterized by having a temporal dimension. The first do this, then do that. So we took us another quiet way to turn this language into a software specification language, but we achieved that as well.
And that is something you have actually achieved and is ready or nearly ready, correct?
Yes, it is ready on paper, and we are now implementing it. Luckily, we don't need to implement it from scratch because we already implemented maybe all the machinery necessary to implement this language. And hopefully in the next month, we can see it running.
Excellent. Tell us a little bit more now that you've done such a great job of outlining the problems, and now we're getting to the solutions that you've engineered and begun engineering and implementing. So let's delve in those. So some of the solutions, and I apologize if I missed them, but some of the big solutions that you've come up with is the Tau language, the Tau meta language, and the Agoras token. So would you like to walk us through each of those solutions, and also any that I missed? I apologize.
Yeah, so what I describe now is the Tau language. TML, Tau meta language, it serves several purposes. First, it is a very powerful execution engine for logical tasks. It is, in many senses, equivalent to relational algebra. Relational algebra is the famous SQL that virtually all databases, all SQL database, all relational databases work with. It is not SQL, but there is a deep connection. But it implements relational algebra in a compressed way. And this kind of representation allows you to to be a powerful logical solver by its own. And the technologies from TML will indeed be used across all our logical tools. Further, TML is also, and this gives it its name, meta-language, is intended to be a compiler-compiler, a tool to write translators from one language to another. So it contains a very powerful parser, maybe the best parser that exists on the market, and tools that allow you to take the parse tree and manipulate it, and by that create translators. So, to sum up, TML main three things is a certain kind of database, of compressed database, that in certain tasks, it is orders of magnitudes faster than other databases. Second is a powerful execution engine, which also incorporates proof of execution. I will explain it in a moment. And language for writing translators. Now, for proof of execution, that's something that we work on. If you give me a program, you ask me to run the program, let's say the program returns yes or no, let's say. So I come back to you, I tell you the program returned yes. How do you know I didn't make it up? How do you know I really ran the program? In an absolute sense, there is no way to convince except something that is equivalent for you running the program yourself again. But then what's the point? Then you could just run it without giving it to me. Turns out that under cryptographic assumptions, I can give you a cryptographic proof that the running was correct. Cryptographic means it's not a logical proof, but it is very hard to fake. So why don't you see it everywhere? Why you cannot right now give program to other people and get a cryptographic certificate? Well, because it requires to convert the program into a very specific form, and that's a big headache. And in TML, because it is converted to the binary decision diagram form, it is already in the form that suits this kind of algorithm. So for TML program, you are able to give a short certificate. And this gives rise to important blockchain feature. Existing blockchain networks with smart contracts, all nodes in the network need to run the smart contracts as part of the block verification process. So the computational capacity of the whole network is as of one home computer. And all the work is repeated. Why not one node runs the contracts and supplies proof to the other nodes that this is the correct answer? And that's indeed yet another aspect of Tau. The proof of execution of contracts or other things in general.
And so the Tau meta language is what enables this distribution of not just computation, but also the proofs. And that relates to the logic and the trust. So Professor Franconi, earlier you mentioned, how do you trust, right? How do you arrive at that place where there's agreement? And that's a bit of what Ohad is mentioning. What is your take or reaction to some of the solutions that you guys have come up with the Tau meta language?
Well, if I can go back with other examples, Ohad mentioned SQL and TML resembling SQL, based with these very powerful data structures, etc. So SQL, database technology, is basically making a business of 17% of all IT. So 70% of all IT money goes to relational database technology. That's what companies do. That's what is really needed. And banks use SQL technologies, and banks don't want their technology to fail. They want their systems to always tell the truth about how much money do they have and how much money do they have to give to other people, and so on and so forth. Transactions have to be trusted. Now, SQL is based on logic. So SQL technology is logic. It's first order logic. Is when it was created in the early 70s, it was created as a formal system. And SQL is a language where you can actually access the data and update the data and manage the data. And it's all based on the notion that the answer is always to any query, or the impact of any update to the data is always trustable, because there are formal proofs, mathematical proofs that tells you that. That's one aspect. And well, I have this joke that I always make that even Microsoft, this is a joke that is good for people of my age, when Microsoft was just a nightmare, right, with Windows crashing all the time, etc., etc. And so then you would say and the question is, how comes that Microsoft has a reliable SQL relational engine? This is SQL Server, which is very popular still nowadays. It always gets the correct answer, so it never fails. Why is that? Because, well, Microsoft have to implement SQL, their own SQL Server engine, by following the logical rules, and they could not do anything else. So that's why. Another example joke that involves Microsoft is, would you trust an airplane which is run by Windows? Would you ever fly on that airplane? Well, probably not, but you do fly on airplanes. Why? Because the software, so the software in airplanes does not built by Tau, but still there is a major technology which uses logic to verify the correctness of programs in complex systems, in safety critical systems like railways, airplanes and stuff. So you can transform your program in some logical form, your software in some logical form, and then you ask to theorem provers questions something like, it will ever be possible that sometimes in the future there will be a configuration of flaps, engines, air conditioning, whatever, failing batteries and stuff, so that at some point this airplane will fall down because of the software. Of course, you want the answer to be no, but you want to trust this answer. You want to ask this question, and you want to trust the answer by the system that tries to answer this question. And these systems are based on logic. They do logic-based software verification, which is a very small part. We also do this. This is somehow similar to the idea of proof that was said by Ohad before, but it's very limited to that particular context. So the notion of trust is what logic gives you for free. And another example why logic is that? I would claim that logic is the only thing that gives you that. It's when we communicate and we start to argue about something, we may argue as much as you wish, but there are some things that I may say that you can never counter-argue, right? There is no way that you cannot trust what I say, because I'm following a logical argumentation. I'm following some patterns of reasoning which are necessarily correct, right? And then, of course, there are ways they can fool you. So I can build an argumentation that is not really correct in terms of logical steps, but you don't fully understand it because I confuse you with words, etc. And so you believe that the argumentation is correct, right? And the point is, logic is exactly the study on which kind of reasoning paths are correct and which not. So once you have done this study, you can build the ideal discussant in any discussion, or you can build a logical theorem prover, a logical system that guarantees that whatever thing you ask them, it's correct, and you cannot really disagree with it. So that's the notion of why this is grounded on logic.
Excellent. Thank you for that. It's always... Oh, go ahead, Ohad.
I need 1 minute to take the charger. Excuse me for 1 minute. Sorry.
Let's see. I don't think we can stop or pause the video. I can stop it, but I don't want to have to restart, so I'll just cut this section out. But yeah, this is great. You guys are really phenomenal at explaining these, and we're building up to the one of the key points. So what I'm going to ask next is about how does the Tau meta language help with building the software and translating meaning between languages, whether it's natural language or controlled language or machine language, and how does that also relate to software specifications? Because that's kind of the heart of what Tau network produces, right? That's the output. Or if you disagree, that's I'm curious to how would you define the output of the Tau network?
I guess that the metaphor, the way I understand it, because I'm just in part of it, that TML is the assembler of the whole endeavor. So there is this high-level languages like, well, this could be the control natural language, but or the Tau language itself, that then is executed over TML. So it's can be understood as such. You can do whatever you want. Of course, it's very low level. So the thing that you can do in TML have to be very specific. And again, it is guaranteed that whatever it does it correctly. But it's too fine-grained, right, somehow. Then Tau is a much more abstract language. It's much closer to the cognition of people using them. So there are the notion of concepts and relations and transitions and programs, so that you can actually express your concept and software in the Tau that then will be compiled into TML. That's my understanding, but probably Ohad has a better way to say it.
Yeah, well, the Tau language is also very low level.
Yes.
Okay.
But it's more
the layer
abstract
to make it,
I guess.
Even more, yes.
Yeah.
The layer to convert from control natural language or natural language to the Tau language, that would be a different layer. But the Tau language had to overcome the theoretical difficulties of speaking about truth of sentences in the same language and having the temporal dimension to allow it to be a specification language. And it achieves this in a mathematical way. If you see the Tau language, it will make little sense to you because it is a mathematical thing. But you can build on top of it something that relates to real life.
So by building, what I guess can you expand on that? Like building something on top of the Tau language, the Tau meta language. How does that connect to the original purpose of Tau, which was that collaboration, the consensus, and the construction of software in a decentralized manner? Because this is the underlying, I don't want to say operating system because it's different, but it's the underpinning technology that facilitates that, correct? That goal of distributed software development.
Yes, but there is one important point to understand here, which is the difference between code and specification. To give an example, suppose you are in a new city, you want to reach from point A to point B, and you don't know how to do that. So you ask someone, and they tell you go straight, third turn to the right, second third turn to the left, and so on. They don't tell you how many meters, but they tell you second turn, first turn, and so on. And you ask another one, and they give you completely different directions that hopefully lead to the same place. How can you compare and make sure that those two sets of instructions lead you to the same place? Well, you cannot. You cannot. At the same way, it is impossible to say that whether two programs are equivalent, as we spoke before. And programs are indeed instructions where the computer has to turn at each moment. But specification, the requirements level are of different nature. Your requirement is to reach from point A to point B. And this is not written in the language of instructions. You will need eventually to get the instructions, but that's not what you really want. Software is still in the Stone Age in this sense. You need to code instructions. Why can't you let your Google Maps calculate the instructions for you in the software analogy? Why can't you just write the what and let the computer figure out the how? Another limitation of traditional coding is that you cannot have global statements. For example, I don't know, I want to reach somewhere and go to a supermarket in the middle. Or a more software example, never send private data over the network. Never send private data over the network is not something you can code. There is no command that says never do that. You need to go over your whole code, all places that you send data, and all places that you declare data as private, and make sure that all pipes are connected correctly. Why can't you say just don't send private data over the network? And that's it. Let it figure it out automatically. Another point. If we take the two directions, instructions of how to reach from point A to point B, you want to ask the question, maybe they are not the same, but where do they agree? Well, that's a meaningless question. But the same way, if you have two different programs and ask where do those two programs agree, that's a meaningless question. But if you have two requirements and ask where those two requirements agree, that's meaningful. Mm-hmm. The way to see, the mathematical way that we look at it, is each requirement is really the set of all programs that meet those requirements. For example, don't send private data over the network is mathematically the set of all programs that don't send private data over the network. And then you come up with another requirement, and which will be another set. And the agreement would be any program that is in both sets. So we have to move from programs to sets of programs. And to your question, how coordination takes place indeed. So everyone can say whatever they want to say about the software, like never send private data over the network. And we look for programs that meet everyone's requirements. If each user would come up with a whole program, and you ask where two programs agree, as we said, that's meaningless. You cannot have programming by consensus, programming by agreement, which is what we do. If you stick to code and programs, you must move to the requirements level.
So, tying it into layers and the procedures, how do we get from discussing, if I express my requirements, don't send my data over the network as one example, and of course there's plenty of requirements. So a software requirement or specification is, as you said, the what, not the how. I tell you what I want, the outcome that I want to achieve. So how do we get from me expressing that in English or any other, French, Italian, German, whatever, any language? How do we get from groups of people expressing that to finding that agreement? Because we've set up all these the pillars of these problems. So Ohad and Professor Franconi, I'd like to, now that we've set the stage, let's watch the play. How do you take those natural language discussions that the three of us have about our requirements? What are the layers of abstraction that need to happen that you have solved to then get from my natural language conversation, your natural language conversation, to get to those requirements and specifications? Can you walk us through that?
I can touch the first step, which is the natural language part, to logic. So this is something that is well known in people studying languages, so linguists and philosophers and psychologists, cognitive psychologists. In particular, more formally, which is the aspect we are interested in, there are scientists that in the 60s and the 70s, from Montague to Chomsky, that completely clarified how and why natural language is related to a logical specification of it. So any sentence that we utter in a language, say in English at this point, has a very precise meaning in some logic. And as we say, it's even too powerful because we can express paradoxes, something like this sentence is false, right? So then I can express this, but I don't want to clearly transform this into logic because, as Ohad explained to us before, this will lead to an undecidable or a paradoxical logic, which would be meaningless for any usage. And indeed, such a sentence is also meaningless for us as a communication mean. So we want to focus on, as I mentioned before, to the very large fragment of meaningful sentences, that we, when we communicate, we can understand each other. Now, how to translate this into a logical form? This is a well-known process, and I guess we inspired ourselves to the Montague work, but it can be done with current technologies. It's what in a sort of non-positive way has been called good old-fashioned AI, right? The GoFi thing, which people doing deep neural networks don't like because, well, this is useless, right? Well, I don't know, because understanding language is probably not useless. And the way people in deep neural networks understand language is they don't understand language. And if you really want to do that, you have to go the other way, the way that philosophers and linguists and psychologists went through. So we can have a logical counterpart of natural language sentences. It's not easy in terms of capturing their own generality. That's why somehow, in terms of real-world application, this endeavor failed. The GoFi did not really deliver a robust natural language system as the deep learning community provides. Because it's much harder, because we want to understand what the language says as opposed to just statistically generate non-understood sentences. Okay, so we can have this logical counterpart. So indeed, then by using logic, for example, we can replicate. This is what Aristotle did in 2,000 years ago. He created the logic of syllogism that corresponds to the argumentation in certain particular patterns. And then once you have this language translated into logic, we can employ logic to check whether whatever we are saying is correct. If you counter argue something against me, I can check. Well, your counter argument is false, so I can easily check, right? So, and that's somehow what our cognition does hiddenly. And that's a really interesting cognitive psychology problem. Why do we trust a good argumentation, and why logic? Well, logic formalizes just this. The logic is just a way to understand why this is true. It's very well understood why logic is the right way to make the argumentation, which has to do with the notion of entailment being grounded on model theory, let's say, something like this. But yeah. So now we have logic, and Ohad can go on.
Pass the torch. Ohad?
Yeah, so from a convenience natural language interface or controlled natural language, it will not be full natural language. You will not speak to the computer the way you speak with other people, but in a more limited way. From there, it should be translated to formal logic, which is a mathematical expression. And from there, all logical reasoning tasks like detecting contradictions or consensus and so on will be done automatically by the very algorithms that we develop to show that a language is decidable, which is what we do. We come up with an algorithm that decides the language. And maybe it is a point to mention a major difficulty in this whole field, which is the necessity, the rare necessity to very much combine theory with engineering. Logic is a very deep theory, and it is also very computationally intensive. Naive implementation of logic is not going to work in real life. You need extremely good engineering as well as extremely good theory, and surprisingly or not, this combination is very rare in the software development world. And I guess this is one of our strength points, and indeed we invest a lot in both fronts.
So thank you both for helping break that down from from language, controlled language, formal logic, and so on. So let's expand this, or maybe look at it from a different angle in terms of so we've talked about the Tau meta language, the Tau language. We've talked about the problems of distributed development of software, and as you mentioned, getting to those specifications, those purely logical expressions as to what we want it to do. But that's not where the Tau network ends, right? That's actually just kind of step one. And after that, as you talked about before, how do we get to the how? How does it do that? How does the network arrive at the actual new software that once people have expressed their requirements, and then as you also mentioned, you find the points of agreement, right? Where do the requirements overlap? Where do they agree? So then what's the next step? Once you find those specifications, how do we get to the how of the software?
Yeah, so starting with the directions analogy. So one says, I want to go to a supermarket, and the other says, I want to go to a restaurant. They feed this to the computer, so Google Maps prepares a route that goes to a supermarket and to a restaurant. And then the self-driving car executes this route. So indeed, after people say what they have to say, we automatically calculate the agreement, we get some kind of specification, and we automatically run the specification. So that's yet another point. The specification is executable indeed, automatically.
So the specification is itself already executable. It doesn't need to be translated to Python or C or anything like that.
That's right. Well, there should be some program that takes the specification and runs it.
Mm-hmm.
So you can look at it implicitly as translating it to machine code.
Okay.
But just like, Java, Python that you mentioned, they are also not compiled languages. There's some interpreter that runs them. And same here. There will be interpreter that runs the Tau language.
Excellent.
I guess that
Excellent.
By pushing the Google Maps metaphor, right, this is exactly what AI does. So you really say, I want to go from A to B, or even take a robot or Google Maps, whatever, and that's all you have to say. Then the system finds the execution path. So this is the path, and this path, of course, there are many, possibly infinite paths, different programs that execute your desires, right? Your desiderata, your specification. So you may give preferences. You can say, well, I want to have the shortest one, or the fastest one, or the cheaper one in terms of fuel they need to use, or whatever. So you have a sort of, among all the possible realization of this specification, because of course there are many, there will be reason to prefer some over others. And so this is a typical AI problem, which in the naive way is implemented as a search problem. So you want to think in terms of a robot. I start a certain position. I know I have to go there. First of all, I can have some heuristics. I can have some way to try first. So I know if I have to go to the city center or to the supermarket, I know that it's in that direction because you see the tower. And However, well, I go in that direction, but then maybe I hit against the wall. Okay, maybe this is not really smart. So, well, I backtrack and I try to go slightly on the left, and then I keep going, trying to go in that direction. So I have some driving force, which is the heuristics. I search for the solution, my potentially failing and backtracking, and then eventually I find the goal. That's how Google Maps finds your paths, the best one, the cheaper one, whatever, using these kind of principles. Now, what is also quite special in the technology employed by Tau, which is fully an idea of Ohad, is that we don't rely these algorithms on search. We don't base these algorithms on search, but we use them based on a different kind of technology, which is Boolean algebras and automata. So in this sense, we avoid also, hopefully somehow, in most of the cases, the hopefully means that you cannot guarantee that the solution will be found in the fastest possible way, but you can approximate the optimality by minimizing the time that you waste by doing wrong choices somehow, right? And then you try to find the best program, the best implementation of your specification in a reasonable amount of time.
Yes, excellent. Okay, so we have, well, I guess before I declare this, are there any other components or topics before we break into the result? What is the final result of Tau, and how are people going to interact with it? And, okay, we have a way, you have described a way to develop software in a decentralized manner with this interpreted language. But kind of the question then is like, okay, so what can we do with decentralized development of software? What is the long-term outcome of this? And how is it going to change my life, your life? How is it going to change the world?
Well, before you even reach the software aspect, one thing that happens at the beginning is everyone just saying what they have to say. Everyone express their opinion that may or may not reflect on how the software should be like. And as a byproduct, you are going to have the most powerful AI in the world controlled by the people, that belongs to the people, not belong to one entity that who knows what their intentions are. Mm-hmm. And it will be the most powerful because so many people train this AI. They just speak like they speak in social networks. I will say that we already uploaded our mind to the cyber. We just didn't do it in machine comprehensible languages. Now that you will re-upload your mind to the cyber in a way that machine can understand you, the consequences of this are bigger than imagination. So that's one big deal that is going to happen from this technology. And then, suppose after you expressed a lot of opinions, now your Tau client knows what you want and knows ways to achieve what you want. It can automatically organize stuff, as long as those stuff live in the computer world, to give you what you want. Whether it is tailor for me a good deal that takes into account my abilities, my skills, my assets, and other people's bids and so on, or how society should be like. And so on. Well, you cannot just go to Google and tell Google, give me what I want. But you will be able to go to Tau and tell it, give me what I want.
So this is what, when I got this, in our earlier conversations, it completely blew my mind, because for me, the difficulty was connecting, okay, formal logic, software specifications, natural language. But what you're saying is, once you have that full stack, all those layers of abstraction, and then because it's not just an individual, it's not just me talking to Tau and it deriving specifications from my words, but it's also doing the same thing for everyone who's participating in Tau and finding those points of agreement. And then it's allowing the Tau network to update itself automatically. And so everyone who participates in a Tau network, and we'll talk a little bit about how that's going to be implemented and deployed in just a moment, but I just want to reiterate for our audience, this is the key innovation here, where by interacting with your Tau client, and as I mentioned, we'll get into the implementation and deployment in a moment, but by interacting with the Tau client over time, it will learn what you want, what you need, and it's all recorded based on those expressions of opinions and needs from our natural language, correct? So it will take that and then translate it into the controlled language, and then further and further abstract it down into formal logic and specifications. But then everyone who's participating in Tau will do the same thing. And as you mentioned, everyone's ideas and needs and requirements and knowledge will become embedded in the whole Tau network. And that means that the Tau network will be as intelligent as everyone participating in it, but not just as individuals. It will record those ideas, abilities, and any new capabilities of the network over time, and it will continue to get smarter. Is that a good summary of kind of how the Tau network is alive in some respects?
Yes, just with one caveat. I don't want the audience to think that you are going to give a natural language sentence and it will understand you and that's it. From natural language to formal language, it will be an interactive process that the user will have to eventually approve the formal statement. But other than that, yes, that's where the system is heading to in the long term, yes.
Excellent. And so how does this help me explain to our audience, because I have an idea in my head of what this collective network intelligence has, because it forms a layer not just for machines to communicate, like, with a blockchain, right? Blockchain is how machines can work together, maintain consensus, but this also allows for humans to communicate seamlessly, not just with each other, but also with the machine layer. And then ultimately, what are the kinds of things that the Tau network can be endowed with? What are the abilities or capabilities or the extensibility of the Tau network? Like, like we talked about like Google Maps and stuff, but that's not even the beginning of what you could do with Tau. So what is the high end? What is the long-term set of capabilities that you can imagine? And like you said, some of it is beyond imagination. But how do we get from where we are today to the limits of our imagination of the Tau network? Walk us through that.
So indeed, the main thing is beyond imagination, but the few things we can imagine. One thing is combining brain power. So I will say that I can give you a solution to all problems in the world. You have a problem, you take the 1 million smartest people in the world, you put them in one room until they solve the problem. Well, but it doesn't work, because how can 1 million people combine the brain power? It's just impossible, as for now. But if the computer understands what they say, it can help in combining the brain power. So that's one thing. Combining brain power in large scale for the first time. Another thing, which is something that we also work on actually implementing, this is going to be a part of Tau, and a big part of what the Agoras token is about is creating an economy of knowledge. You can trade single pieces of knowledge directly. And indeed, we spoke about training the machine, formalizing knowledge, and so on. If there is also financial incentive to do so, you can expect orders of magnitudes more activity.
And that is the Agoras token that you're referring to?
Yeah. Agoras, yes. So another thing is, as you know, people are very worried about AI doing bad stuff. And as we said before about the laws of robotics, the existing field of mathematical logic does not know how to make sure that the next software update will maintain the laws of robotics. And that's a very serious problem concerning AI safety. But how solve this problem? And how you will be able to reject undesired future behavior.
And so to get to that point, all the users of Tau will at some point express that opinion through controlled language, through that process that you mentioned of, working with the machine to express your desire. But say, for instance, we collectively put in a requirement into the Tau network, like, don't ever launch nuclear missiles, right? That's the Skynet solution that everyone is afraid of. So is that can we literally work on that with Tau, like don't ever launch nuclear weapons or something along those lines? Like you said, the contradictions or the restraints, the rejecting of instructions or coding or other things. How is that how that works?
Yes, whatever you are able to say in the language will happen for sure. But the difficulty is to say what you want to say in the language indeed.
Right.
To write a whole design, a whole book in natural language is also hard. It's not because it's logic then it becomes hard. It's hard also in natural language. This difficulty is not going to disappear. Maybe it can be spread among many people because of the combining brain power aspect we spoke about. Mm-hmm. But it's not going to be fully automatic, fully easy. No.
So let's take that example of creating a constraint, a limitation on the Tau network of something that it must not do, right? Expressed in formal logic. But let's look more beneficial, more utopian. What if we were to say something like, how would it go about implementing something like, let's say everyone on the Tau networks had defined the how or the what, right? The specification of make sure everyone is fed, make sure that there's no hunger on the planet. Is that something that could be expressed in the Tau language, Tau meta language, and then implemented? And how would that work, or how would that look? And obviously it'll take a little while to get to something like that. But is that the kind of thing, because that's something I can imagine. Is that the kind of thing that is possible or feasible, in the next 5 to 10 years?
Well, to just express that, of course you can express, but you will need to express so much more to reach a level that the system knows how to achieve it. Okay.
So there's implicit prerequisites in order to achieve that outcome, but that outcome could be expressed in the Tau network, and then through the process of conversation or negotiation or exploring those other requirements to work up to something along those lines, or all the prerequisite steps rather.
Yes, Tau will take what you tell it as is, with no modification and no guessing, and automatically draw the conclusions. So as long as you gave it the means, whether explicitly or implicitly, to achieve what you want, it will achieve it. Well, with a small caveat of the time it takes the computer to compute such stuff. But ignoring this caveat, it will achieve it.
Well,
okay, so go ahead.
Yeah. So just to complement that, I guess similarly to the success of current deep neural networks, that basically they do this analysis, statistical analysis of so many things that were said in the past, so that they can have an idea of what could be meaningful and what is not, having looked at what is this. Similarly here, but in a completely different levels, because again, with the notion of trust added, is that in order to achieve interesting conclusion, the system has to have knowledge. So I can imagine that at the beginning, Tau will be quite stupid in the sense that it does not have a lot of common sense knowledge to reach interesting conclusion for us humans. In certain fields, for example, if you focus on software engineering, well, yes, because you don't really need common sense there. But if you make these examples of nuclear weapons or whatever, then that's another level of thing. However, what is interesting is that people, by using Tau, will add knowledge that, since the common sense knowledge is knowledge that we all of us have, even though we don't know that we have. But it's this, all of us, it's interesting because somehow it's all this knowledge that we already have an agreement about. We all know that elephants don't fly, right? And at some point, possibly, I guess, because of this consensus mechanism, this will be just a fact for Tau, right? And so it will build slowly all this common sense knowledge because everybody agrees on this implicitly. And again, since we are using logic, then all these implicit facts are also important. So whenever you make a statement that does something implicit, well, this it's not explicitly said, but it's true anyway because it's implicit. And so Tau will grow up and acquire all this common sense knowledge. The other thing I wanted to mention is the idea of the law of robotics, because Tau can also take a very nasty direction if people want. So maybe the majority wants to vote for having a dictator. So since they can change the rules, they can change the agreement rules, they can change how the system evolves, they can say, well, only if we get the approval by your preferred dictator. So you have this person that, because everybody agrees that they want to pass all the agreements through this person or to this agent, whatever, just to mention an example. Now, this means that since now this is the new mechanism of agreement, you cannot change this, right? Because it's a law it's a constitution, and to change this, you have to apply this rule itself. So only with the approval of the dictator, you can change the rule that he is the dictator.
That's if that gets approved in the first place.
Yes, indeed.
But it might not ever get approved.
So that's why I also conceive that there may be branches, different realities of Tau, that the one which has a dictatorship or something like countries, right? People that create their own majority, religious subgroups that create a religious reality or whatever, right? So that's also interesting, I guess.
So what you're saying is that could be a smaller implementation, or an isolated Tau network might end up with that set of rules.
Yeah.
Okay. Now, but what if, so here's where after learning about this and I was just thinking about it, what if Tau ends up much broader, like across entire nations or continents or global? Is that part of the vision? Is that part of the dream where everyone is interacting with the same Tau network and it becomes collectively more intelligent and has the knowledge and capabilities of all humans across the whole planet? Is that part of the dream? Because that's to me, that's where my imagination goes with the technology that you guys have outlined.
Well, I believe that anyone should have a significant voice, and Tau is indeed a voice amplifier, and you may ask, well, if you amplify everyone's voice, then what's the point? Then you remain with the noise, but, well, it does the magic of amplifying all voices without having the noise. And I personally, yes, I want to see everyone saying their opinion, and society takes everyone into account. Whether governments want that or will go this direction, I don't know.
Right. It wouldn't even have to be like, I guess a government could adopt it, right? Like one early step, and I've discussed this concept with other folks, is using DAOs, distributed autonomous organizations, for like townships or homeowners associations. That could be a first step. But yeah, it wouldn't necessarily need to be adopted by governments. But if it's by voluntary participation, right? If I can decide to set up a Tau node on my phone, and then I'm participating in the Tau network, it's almost like nobody could stop it either. Is that a possible future? Is that's one of the natures, the robust natures of blockchain, is that it's difficult to turn off.
Yes, just like since the most revolutionary thing ever happened in history is the internet. And indeed, people say what they say in the internet. They try to stop it. Yes, now we have a lot of censorship. But people still, to a large extent, able to say what they have to say, although it is propagated only for people who read them. There is a limit to how many people you can read every day.
Mm.
With Tau, you are going to see a summarized map of what everyone says. Because it can be that two people have three opinions, but in a million people, there will not be a million opinions. There will be a lot of overlap.
Mm. So you can aggregate and summarize and cluster not just people as a whole, but their opinions. And so it says you overlap with this group over here, and that's part of that finding consensus or finding agreement in arbitrarily large populations.
Definitely, and this is what we call the opinion map. So the opinion map shows who agrees with who disagrees with who, and where is the consensus. So you can think about a Twitter feed or Facebook feed. They look like this user said that. This user said that. Imagine you could say it, this opinion is held by those and those users. The other way around.
So let me throw a hypothetical into this. Is let's imagine a future where there's millions of Tau users, and there are opinions that are diametrically opposed, that are mutually exclusive. Does the Tau network try to reconcile that, or is the answer it just doesn't address that issue if there's that level of antagonism? How does that work in the network?
Tau will never guess and will never put words in your mouth. It will always be exactly what you told it. That's the whole point of using logic.
Okay. But I guess maybe not Tau, but let's say if my opinion is we should feed everyone, and that, I express that opinion, and your opinion is we shouldn't feed anyone. People should feed themselves. And so if those two opinions are expressed in formal logic, at least to my, amateur brain, they seem like they're mutually exclusive, right? Is that right? And so how would that be reconciled in the Tau network, or would it not be reconciled?
It will not be. It is a contradiction, and there is a disagreement. Okay, what to do? So there are ways to mitigate it. We think about creating a mechanism of debate, which is kind of a game. Debate is kind of a game. Mm-hmm. Another thing is what consensus means. So we can say this thing that everyone agrees on, or the majority agrees on, and so on. And this can also change with time.
Mm-hmm.
Bottom line, the users will have to define how to address these situations. There is no out-of-the-box solution.
I see. So to walk through a hypothetical where there's any point of contention, whatever the topic is, if there can be no agreement on any particular solution, part of what happens moving forward is there might be discussion about even how to make the decision. What are the decision criteria, or what are the other, like there might be a debate mechanism, as you said, or there could be, maybe the rule is set that you only need 98% majority vote, and if 2% disagree, they get ignored, or, but any rules can be conjured up and eventually applied through the Tau network.
And that's why you need to change the laws of changing the laws. That's right.
Exactly. This is phenomenal. It still blows my mind when I sit and think about the potential power of this network, because it is a learning network. It is a new kind of collective intelligence or hive mind almost, between humans and machines. So I want to, then of course I'm excited about this, and I'll continue rambling about it forever, but I want to hear, Professor Franconi, you haven't said much in the last 10 minutes or so. Where do you see Tau going? Obviously you're committed to this project. What is your personal dream? What do you want to see happen?
Well, tend to be more pragmatic and less of a dreamer in the sense of, well, dream does not mean unachievable. Means longer-term dream. I have a shorter-term dream, and I really see this already applicable, as it was mentioned before, in these small communities. I mean, like now we have several blockchain systems, maybe each one working with different kind of rules, smart contracts. For example, the area of smart contracts, I think, has a natural application here. So now smart contracts are a piece of code that nobody understands, and you can be fooled by anybody because you give a directive to do something, and then the way it is actually implemented is completely disconnected from what was my specification of what this smart contract should be. So just this small area of application where you have to negotiate an agreement between all the parties involved in the contract is a major area of application to me. So I'm much more for experimenting, but that's just me, right? Experimenting in these small confined areas where you can actually understand and focus potentially also on problems and mess them up, in particular social problems that have to be understood to potentially solve the bottlenecks that may arise, etc., etc. I'm very fond of all the technical solution that we have found, that the Ohad and his genius group is really working hard on this. There is the open problem, which is not a problem. There is the goal to start applying and see these things really in the real world, deployed in the real world.
Excellent. Yeah. Ohad, what's your dream, short or long-term dream for Tau?
Well, Tau is all about truth. It is for people like me, like us, who like the truth, who prefer the truth over the false. I hope that I will bring a little bit more truth to this world, to this full of lies world.
Excellent. Okay. So we're nearing the end of this conversation. What are the next steps for Tau? What's coming down the pipeline? Where are we at? And then how do people get involved? Let's talk about from this day forward, what's happening with Tau and what is the level of involvement for people like me and people in our audience?
And for involvement, we have a community mainly taking place on Telegram. We also have a monthly update every month on YouTube, and people can submit questions. And for the next steps, we are now moving to finalize and implement the Tau language, and in parallel, see how to put it as a block acceptance condition on a blockchain, and finally to start having a self-amending blockchain. And so those are the next steps.
Excellent. Yeah, and so it's coming to fruition. It's about to be live on the network. What are just as a final question, what are the key problems left to solve, if any? Are there any hurdles or Franconi? It seems like you have an idea of what are the major problems left to solve.
Well, it depends on the meaning of the word problem. So I see interesting challenges to still be solved and making Tau even more powerful. So I think we have cracked down the main issues, the main quests, by having this language that is able, in a logic fashion, to talk about itself, to talk about laws, to change the laws, the dynamic aspects, to model software, to be very powerful and still be indecidable so that we have terminating correct algorithms. There are new things that we can add to this language, new aspects, to add its expressivity. So we mentioned, I guess, briefly that the language, if we take the most powerful language, then this would be undecidable, so we cannot really hope to implement it. But we taking the decidable fragment is sort of arbitrary. So we took one direction, and so we can still hope to give it more potential and somehow make it more interesting for several aspects. For example, to model formally the notion of argumentation. I know there are some aspects in this, so this sort of game theory that will be involved in argumentation could be a possible extension of the language. So there are many interesting challenges, which does not mean that we have problems. These are just new things we want to add to the language. So that's
okay. So just levels of achievement, but there's no technical hurdles preventing you from moving forward at this point.
Well,
or are there?
There are details to be ironed out, but yeah, I guess the main things are there. Yes. Ohad, what do you think?
Excellent.
Yes, I agree. And indeed, an ongoing effort that we know mathematically that will never end is to enhance the expressiveness of the language and to have a more efficient algorithms.
Okay, so expanding expressions and optimization, but as you said, those that will never end. That is just part of the ongoing work. Excellent. As any final thoughts, one or two sentences from each of you. Any final thoughts that you would like the world to know about Tau before we close our conversation for the day?
Well, I can see my perspective is a very focused on the technical aspect. So I'm not really the one that has the conquering the word and changing the word and pushing for truth in the word. From that perspective, I really think that what we have done is really magic, is major technical advances in logic and computational logic. And this gives the company a major advantage, business advantage too, because we are the only owner. So Tau, the company ITNI, is the only owner of this technology, and so they can do these things, and nobody still knows how do we get these results, and which is interesting as well. So that's and then I really like to keep going working on with the group, and then to meet these new challenges and extensions of the language.
Excellent, thank you. Ohad, any final thoughts for the world?
So to take it more down to earth, we want to take software development to the next level. That much more complex will be able to be programmed and controlled by users to bring software back to the people.
Wonderful. Well, thank you both so very much for bringing me into the Tau group and having your folks reach out. This has been a remarkable set of conversations leading up to this, and I get chills just thinking about what it is that you're doing and the long-term implications and just how deeply fascinating and complex it is. So again, thank you for the talk today, and I look forward to continuing those conversations and seeing where everything goes. So thank you.
Thank you to you.
Thank you so much.
Cheers.
Cheers.